Hi, I'm Travis Elliott with National Control Devices, and welcome back to my desk for the second part of our Reactor Logic series. In this part of the video, we're going to start off by talking about the three keys to the reactor, the three keys to unlocking how reactor logic works. Once you understand all three of these key things, you'll be well on your way to using the reactor control in your own application. So let's get started with that. The first key is inputs. The second is events. And the third is relays, also known as output. Now in this video, we're going to start with the first part of this, which is inputs. To briefly describe the other two, events are things such as timers and rotations. We'll get into that more in the next video. Relays are basically the relays on your board that you're controlling. So how you control them depends on the first two elements. So to start with, let's get into inputs. Now, as I said in the previous video, inputs on your controller are these screw terminal ports where you can attach your sensors, contact closures, voltages, things like that. So let's talk about first, what can you attach to these controllers? Well, first thing, you can attach contact closures. Things such as buttons and motion detectors, a lot of thermostats or contact closures, those are things that can be attached to the controller and that the reactor can read as valid input to carry out an event or trigger a relay directly. We're going to show you a little video clip here, and what's happening in this video clip is a button has been attached to the input of the device. The device is being viewed over our configuration utility. So you can actually see that button generating a contact closure on the relay live on the configuration utility. So we'll show you that video now. In this video, you'll see how a button is viewed in the configuration program. The button is attached to the reactor, and then the reactor is attached to the computer. The computer runs a configuration utility, and we can see live the contact closure detected by the configuration utility from the button. When the button is pushed, you'll see analog input 1 go high and go low. Now that's very simple. So what you can do is once you read that contact closure on that input, you can take that data and tell the reactor what to do with it. You could tell it to just turn on a relay. So if you push a button, a relay comes on. You can have it trigger a timer or a rotation, which would be an event. So those are basically what you do with input after you get it. So the first one was a contact closure. The second valid input would be a variable resistance. Now, a lot of sensors in the electronic market have variable resistance output. What that means is if you're talking about something like, let's say, a flex sensor that we're getting ready to show you, the more the sensor is flexed, the higher the resistance gets. The straighter it is, the less the resistance. The controller can read this variability in resistance, and then you can use that scale to trigger a relay. So if it gets up to, let's say, 150, you could have it turn on a relay or trigger an event such as a timer or a rotation. So we're going to show you a video now. You'll actually see the sensor being read through a voltmeter, and then you'll see how that sensor actually reads on a configuration utility through the reactor controller. So here's that video. In this video, we're going to show you how this variable resistance flex sensor works. We've attached it to a multimeter, and you can read the resistance on the multimeter screen. The further it's flexed, the higher the resistance. When it's straightened out, it's somewhere around 9K. When it's fully flexed, it goes all the way up to somewhere around 22K. Now we can read this variable resistance output with our reactor controller, and we can actually display it live on the configuration screen. We're going to show you that now. This is how you set parameters of when you want an event or a relay to trigger. Here we have the flex sensor set up with the configuration utility. And you can see the flex sensor actually changing analog to digital input 1 when it's flexed or released. You'll see whenever it's fully released, it registers somewhere around 117 or so. Whenever it's fully flexed, it registers all the way up to about 172 to 173. Here we're going to show you the flex sensor in action, actually controlling relays. This variable resistance reading has been tied to all 8 relays. The relays have been configured to come on at different points of resistance, or different points on the A to D scale. So when the sensor's flexed, more relays come on, and whenever it's released, the relays go off. Okay, so that's a variable resistance output sensor being attached to an input. Now you can also attach a 0 to 5 volt DC line. Some sensors generate 0 to 5 volts DC. A lot of PLCs and things like that have 0 to 5 volt TTL lines. This is also a valid input for the reactor. If you apply a 0 to 5 volt DC line to it, it can read that line. So we're going to show you here is a couple of battery packs. We're going to show you the voltage of each battery pack, and then we're going to show them individually attached to the controller. So in essence, you can see that the larger voltage pack registers higher on the scale, whereas the lower voltage pack registers lower. Now, the reactor could be used as a battery checker per se, or a voltmeter. Basically what you do is you take 5 volts and you divide it by 255. That's going to give you the number of incremental changes in voltage, the amount of each step in incremental change in the voltage. So you can take whatever that number is, like say 200, it registers 200 on the 0 to 255 scale. You'll take that 200 and multiply it by 5 volts divided by 255, and that would give you what the actual voltage is on that scale. So I won't get into that too much. That's just some lazy talk there. So here's the video of the battery packs being attached. In this video, we're going to show you how the reactor reacts to voltages attached to its inputs. Here we're measuring the voltage of 2 different battery packs. You'll see the second battery pack has a lower voltage than the first. Keep that in mind for the next part of this video. Now you'll see the larger battery pack attached to analog input 1 and the smaller attached to analog input 8. You can see whenever I disconnect this battery pack from analog input 1, it disappears. Then when I reconnect it, it reappears. This is the reactor reading the voltage levels of the lines attached to the analog inputs. These could be variable voltage, but we don't have any variable voltage sensors, so we're showing you using simple batteries. Okay, so those are basically our 3 types of valid input to the reactor and key fob controllers. Those are the 3 things that you can attach to its inputs. So that really gives you a lot of different things that can be attached to the reactor or key fob. Pretty much any type of sensor you can think of, whether it be a pressure sensor, light sensor, temperature sensor, flex sensor, reflectivity sensor. There's an an enormous amount of sensors on the market, and usually you can find every one of those with a variable resistance output, and that reads very well on the reactor. So now let's talk about the actual hardware of the inputs. We already kind of talked about, they can be screw terminals or these wire spring connections. But let's talk about some restraints with these inputs. You have to remember, you can only apply 0 to 5 volts DC if you're applying voltage. No AC voltage. Absolutely no AC voltage. Never apply a voltage that's less than 5 volts DC. So never apply a voltage that's less than 0. So never apply a negative voltage. So if you took that battery pack and on these inputs you have a ground and an AD1. If I were to take those battery packs and attach them backwards so that I had the ground of the battery attached to the AD1 and the positive of the battery pack attached to the ground, you're actually applying a negative voltage. You never want to do that. So never apply negative voltage to the controller. Also, with DC voltage, never exceed 5 volts. It can only go up to 5 volts DC. Okay? Another thing, never apply power when controller is off. Well, that was pretty much ridiculous for me to write that whole thing out, but you get the gist of it. That's very important. Never apply voltage to these inputs if the controller doesn't have power, which means if that little light isn't on right there, make sure you don't have any power attached here. So if you're going to wire up some voltage to this controller at 0 to 5 volt DC voltage, make sure you plug the device in. Then make sure you remove that device from those inputs and then unplug the controller. So also always remember that. Now that pretty well covers the restrictions on the inputs. So now we've talked about what a valid input is to the reactor. We've talked about what not to attach the inputs of the reactor. And that kind of gives you a good idea of what inputs to the reactor are and how it reads those inputs and how they appear on your screen. Whenever you're looking at the flex sensor, you could see the more you flex it and the higher the resistance is, you could see that scale go up and down. So you can pick a spot on that scale where it's moving between and you can set a point there. And you can say, if it crosses this point, I want to trigger a relay or trigger an event. You can say, if it's within a boundary, I want to trigger a relay. There's a whole bunch of different things you can do there. We'll get into those more later on how you actually use the inputs to trigger events and relays. We'll probably use the software and things like that to show you that. So let's talk about how once something is read into the input, how it travels throughout the reactor. We're going to go back to the 3 key building blocks of the reactor again. You've got inputs, you've got events, and you have your relays. Now the reactor makes decisions based on its inputs and based on the configuration that you load into it. Basically what it's supposed to do whenever it reads an input. That's the configuration you load into it. So I could tell the reactor if, let's say it detects a button push on input 1, like we showed you, I want you to turn on a relay. That is the simplest form of reactor logic that there is. And we'll actually show you a little video here of a button controlling a relay directly. In this video, we're going to show you 2 different types of buttons controlling relays. The left one being used now is a momentary push on release off button. It has to be held down. The button that's being used here is a toggle button. When you push it, the relay comes on, and when you push it again, the relay goes off. This is a simple form of inputs controlling relays on a reactor. Alright, that's really pretty simple. So, like I said, that's the simplest form. If you're going to use it for that, you really don't have your work cut out for you. That's really very simple to do. A key fob button push can also trigger a relay directly, as shown in this video. In this video, we'll show you a key fob controlling a relay directly. When button 1 is pushed, the relay comes on, and when button 2 is pushed, the relay goes off. Now remember, that key fob is just generating it's basically triggering one of the inputs of the board. And if you're using a key fob controller, then you need to know how that key fob actually works with the reactor. Think of it as the reactor has 8 valid inputs. Okay, this happens to be a key fob controller here. They have 8 valid inputs that I can apply contact closures, variable resistance sensors, or 0 to 5 volts to. You'll notice on your key fob controller you don't have 8 inputs here. That's because 5 of the inputs have been dedicated to your key fob. Now, if you happen to have more than 5 buttons on your key fob, if you have an 8-button key fob, you can actually change these little jumpers here so that you can dedicate these inputs to the key fob or to these A to D inputs, so you have the option. Now, think of it as this button on this key fob is an input to the reactor. This button 1 would be analog input 1 on your configuration utility screen. So we'll show that to you now, where when we push a button, basically you can see that input being triggered by that button. So here's that video. In this video, we'll show you how the reactor and the configuration utility react to button pushes on a key fob. You'll see whenever button 2 is pushed, analog input 2 is triggered. When button 4 is pushed here, analog input 4 is triggered. And when button 3 here is pushed, analog input 3 is triggered. So that's how a key fob communicates to the reactor, and how the reactor depicts that key fob button has been pushed. It just reads it as an input. Pretty simple stuff. So it's no different than wiring a button up. Really easy. So those would be the ways that you could use an input to control a relay directly. Now that's really easy, but let's talk about something that might be a little more complicated. How about an input that triggers an event, and then the event controls the relays? So the input doesn't actually control a relay. The input actually controls an event, such as a timer. Then we can have the timer control the relay. So this is how it would travel, logic would travel through the reactor if you were using a timer and you were triggering that timer with one of your inputs. Basically, you would push a button, and then a timer would be triggered to come on for, a couple of seconds. And we would say, when timer 1 is on, which is what this event is, timer 1, then the relay will be on. So basically, you turn on the timer, it comes on for the specified amount of time that you told it to, and then it goes back off. So the relay comes on for that time and then goes off. That's really pretty simple too, and we've got a little video here just to show you a simple timer coming on and controlling a relay. In this video, we'll show you a simple timer controlling a relay. When the input is triggered, the timer starts. Then the timer triggers the relay. Once the timer is finished, the relay goes back off. You'll see later on here, we actually use a second button to cancel the timer. So you can start the timer with one button and cancel it with the second if need be. Alright, so now that you've got that under your belt, let's talk about having an input trigger multiple events. What we've done in this video is we've actually wired all the inputs together. So whenever you push one button, all the inputs detect a contact closure. Each one of those inputs controls a timer, and each one of those timers controls a relay. So by pushing that one button, I triggered 8 inputs, which triggered 8 timers, which triggered 8 relays. One input, 8 timers, 8 relays. This is just as simple. We're just doing a whole bunch of them at once. So here's a little video clip of 8 timers being controlled by relays. You'll notice the relays come on for a specified amount of time and then they go off all in their own order depending on the time that was programmed into that particular timer. In this video, you'll see one input trigger 8 timers at once. The timers expire as according to the configuration we loaded into the controller. So as they expire at different times, the relays go off at different times. Here you'll see a second button used to cancel all the timers. Alright, so that's a very simple way that logic flows through the reactor. And this is how inputs trigger things to happen on the reactor. The inputs are absolutely your door into the reactor. That's how you get your message across to the reactor, is through its inputs. So now let's talk about something that would be a little more advanced. I could have an input start an event whenever I push a button, or a light goes on or off and a light detector reads it. Any type of input triggers an event. I could have that event trigger another event, and then I could have that event trigger a relay. So think of it like this. What if I wanted to push a button, 10 seconds later a relay comes on, and then 30 seconds later the relay goes back off? What I've actually done is I've used 2 timers. And what I've done is at the end of timer 1, timer 2 starts. And then it goes off and that's it. That's called event piping. Now for most reactor configurations, you're going to use some form of event piping, where an event triggers another event. That's called event piping. So what's happening is whenever I push that button, it's going to trigger, let's say, timer 1. We'll just call that T1. T1 is a 10-second timer. No relays are tied to timer 1. Timer 1 just comes on and goes off, and that's all that it does. But what happens is at the end of timer 1, timer 2 is triggered for, let's say, 15 seconds. So timer 1 comes on for 10 seconds, and then at the end of it, it triggers timer 2 to come on. Timer 2 turns on a relay, and once it goes off, the relay goes off. So what's happened is I pushed a button, my input, I triggered an event, timer 1, that event triggered the next event, timer 2, and timer 2 triggers the relay. So basically, I just got a time delay relay that comes on for 15 seconds. This may seem daunting at first, but it really isn't very easy once you get your mind wrapped around it and how everything works. It's extremely simple with the configuration utility. I don't think you're going to have any problems. By the time you get to the end of this whole reactor series, I promise this is all going to seem real easy. And then we're going to start doing some applications. And you can walk through these applications with me, and we can actually set some devices up together. And by the time you watch this and watch a couple application videos, you're going to have a real good grasp on how this thing works. So I think you're going to have a lot of fun with it. And the next part, we're going to talk about events. Now, I'm probably going to spend a lot of time on that because there's a lot to know on events, and we've got a lot to cover. But once we get through that, you're going to have a pretty good idea on how this thing works. So be sure and stay tuned and check out part 3 of the Reactor Logic series. Thank you.